From Chicago, welcome to 3 Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Probably the best thing that happened to me in my career actually was getting laid off. Right, so I got laid off of GE Healthcare on the same day as 24,400 or some other number of other people. One of the kind of cullings of the herd days, and that was a wake up call. I within a few weeks I had a network and I found someplace else to work. It was working on different high temperature materials, and it was pretty interesting. And then I got laid off from that company about 14 months after getting laid off from GE. So then I was like, okay, screw this, working for somebody else. Started my own business. Sound familiar?
That's Kirk Rogers. Kirk is a technical excellence leader at the Barnes Global Advisors. For the last 10 years, Kirk has used additive technologies to solve manufacturing, repair, and supply chain problems. He recently was the technical leader on the startup of a $40 million additive manufacturing R&D center, culminating in a nearly 20-year career at GE. Most of Kirk's career has been in the medical device manufacturing realm, where he built manufacturing lines for qualified numerous products. Kirk has 25 years of experience in materials processing and business strategy. He obtained his BS in materials engineering from Case Western Reserve University, a PhD in material science and engineering from Purdue. He completed his postdoc work at The Ohio State University and is certified Six Sigma black belt. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher.
All right, Kirk, thank you for joining the show today. Excited for the conversation today. Let's start kind of from the beginning. Tell me about a young Kirk Rogers. Kind of what were you doing? How you were getting in trouble, and how did you kind of get on the path towards engineering, manufacturing?
Yeah, how early do you want to go? I guess. I mean, I say I was pre-programmed from a young age. My grandfather got his PhD from University of Cincinnati. And, from as long as I can remember, he was always pushing engineering, and he really, really wanted me to do a co-op program, which I didn't. But I was resistant to the engineering. I mean, really until junior year in high school. Typically got in trouble. I rode my bike places I wasn't supposed to. Ran across a multi-lane highway just to see if you could make it before the cars got there. Probably did some things I won't mention that required evasion from neighborhood police, and rode motorcycles where we weren't supposed to go, and all kinds of interesting things. I'd say that probably the strange one is one year I had a summer job, and I was using a neighbor's lawnmower to cut his lawn, and I ran over the cord. And so it was a plug-in electric lawnmower at the time, since there was no such thing as battery electric lawnmowers. And so you think this was going to be an epic fail, but he was happy because he hated the lawnmower anyway, which is probably why I was mowing his lawn, not because it made me money. But I took that control panel, which had a delay fuse in it, and I built a spot welder. I was probably 10 years old at the time.
Wow. And are you originally from the Ohio area? Was that?
No, I'm originally from Buffalo, New York.
Okay.
So I moved to Ohio to come to Case to go to engineering school.
Got it.
And so, that's where my love of Cleveland started. So it's a small city, and it's not unlike Chicago. We're just with, nearly as much stuff to do and half the hassle. So I've lived in Chicago. So it was where I spent most of my adult life. But so you asked me really where did we come into, engineering? And I'll say that really what got me into engineering was an article in Bicycling Magazine in probably summer of 1986, maybe 1985. It was about the materials used to build bike frames and components and stuff. And so at the time, most everything was made out of steel or aluminum, and you had composite bikes starting to come out. You had different kinds of aluminum frames. Some were welded, some were bonded, lugs bonded to tubes of different chemistries or different aluminum alloys, and there's some other unique things that don't exist anymore. And that's really kind of what sparked the material scientist in me. And that's kind of sent me on this path now that I've been on 35 years in love with materials.
That's awesome. It's very similar to kind of where I found materials was for baseball bats. The same progression as bikes, right? Like aluminum, exactly. A little bit of titanium, but kind of composites and that tangible feel of like, hey, like this, when you switch materials, it actually makes a difference. You can see it and feel it for yourself.
Yeah, absolutely. I mean, at the time I had an aluminum frame bike and a steel framed bike, and they were completely different. One of them weighed half as much as the other. I'll let the viewer guess which one weighed less than the other.
And so with materials, was that like for me, like when I didn't know what materials engineering was going into kind of college, was that something on your radar, like that sort of program, or had you the article, but you kind of knew what it was?
The article didn't really necessarily mention material science as a degree that I remember, but I did go and see my college counselor that fall, and I was like, "Hey, what's this?" And he's like, "Well, I think there's this field called material science. There's a few schools that have degrees in that. Maybe you should do there." And then, did a little investigating and decided that I'd be going to Lehigh, Virginia Tech, or where else did I go? I had like 3 or 4 schools. And then I got random mailers from this small school in Cleveland, Ohio called Case Western Reserve University. Who ever heard of that place, right? As a high schooler, big name schools. And lo and behold, I visited Case and fell in love and spent 4 years there. So kind of growing as an engineer and growing as a human in a uniquely right next to downtown, very, very academic environment, which is cool.
And so what sort of projects were you doing, internships, or kind of did you kind of find a focus of like what aspect of material science that you liked or you were kind of drawn to?
No, I'll say I singularly lacked focus. Undergraduate project I did on bone, so on human bone. And I remember I wrote a thing called article called on the stress generated potential in wet bone, right? Because hydroxyapatite, the mineral component of bone, is piezoelectric, and it's essentially a small electric currents which osteocytes respond to. That is the stress that we put on our bones through daily activities, and to make more bone and make stronger bones. And so that was really interesting at the time. And then, the next summer I worked at a steel mill, which is very, 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 very different, right? Well, I say steel mill, but I really worked in a technology center like 20 miles away from a steel mill. And occasionally got to drive down into the mill to pick up samples and stuff like that.
That's kind of the cool part, right? Is like the material science kind of background gives you this toolkit to like see problems from a specific angle, whether they're applied in medical or kind of industrial, like steels or whatever it may be.
Yeah. I mean, the other thing that really, for me, really helped is being able to think about the same thing on 3 or 4, at least 3 different size scales. So, what's happening at the atom level, what's happening at the grain level, what's happening at the macro level. Right? And that's not something you get from many other fields.
For sure.
So to me, it's still cool after, like I said, 35 years, it's still cool that, that you solve problems. And, I get an email from somebody the other day who's having a corrosion problem. And, it's like, okay, let's do a little research. And I've asked 3 times now what the microstructure looks like. And I've gotten 0 pictures of grains and microstructure. So I still don't know what the problem is and how to fix it.
And so as you were kind of pursuing your academic career, kind of where did like kind of the industry piece kind of come into it? Did you have kind of companies on your radar? What were like, was any of that planned out? Was it kind
Oh,
of?
no. No. So, finished case in the early 90s. The job market wasn't good. We were just exiting recession. And really, it was easiest to go to graduate school. And so I applied to 5 or 6 graduate schools and thankfully got into one because I had no job offers. And that landed me at Purdue, which was, a very different environment, suddenly going from a small private school to a Big Ten campus. Was a terrific opportunity. Right? And so Purdue really was focused on getting a master's degree. I got asked to stay after my master's degree because I was the first potential PhD student that my advisor had because he was new. So we're two young guns kind of figuring our way through the PhD program together. And so I stayed for a PhD and then was really on the faculty plan. I was thinking about, okay, I'm going to be Professor Kirk and, what's that going to look like to the point where somebody I knew more or less wrote me a postdoc job description and offered something even before I'd finished my PhD. And so, I did that. And here's where the interesting part comes is that I had a visiting scientist work for me and I had a few other people working for me during my postdoc. And I wrote a recommendation letter to a General Electric company for somebody who had worked for me, right? Just like you do. And a couple of days later, I got a phone call from somebody who worked at this company that I used to go to graduate school with a couple of years before saying, hey, you'd be a better candidate for this job than the guy you just wrote the recommendation letter for. Why don't you apply? And so I did. And I apologized to the guy that I wrote the recommendation letter for. And, a couple months later, started working at GE Healthcare, working refractory metals, which is completely different than steel and is completely different than bone.
So what was the appeal for the
appeal was, another place with very unique technology. So, an opportunity to really dig into breast and sinter metallurgy. And sort of the mission around GE Healthcare at the time was, saving lives. And so both the saving lives, the end product mission and the technical, day-to-day work were both really appealing. So, I spent a number of years there.
So talk a little bit about kind of the environment within GE. So GE is a massive company. I think everyone knows the name, but it's got different groups and different subdivisions and things. So where did at the time, because it's all evolved, I'm guessing since, but kind of where did GE Healthcare kind of fit and what sort of products or what was their mission other than saving lives, obviously, but kind of what more did they do in kind of that space, or what was kind of your focus kind of close by that?
So when I joined, GE Healthcare was listed in the annual report under miscellaneous other industrial businesses.
Oh, probably $5 billion, right?
Yeah, it was like 2, but
okay.
But yeah, so it was not a focus of General Electric company. It was really sort of a historical business that they had the technology for and supported. And then a guy named Jeff Immelt became the CEO of healthcare, and made a whole bunch of acquisitions, and then it became one of the big, well-known business units of the General Electric Corporation. At the time when I started, it was really, really focused on diagnostic imaging. And so, I would say 90% of the product line was using X-rays to look through, or X-rays or magnetic waves to look at a patient through, X-ray, CT, and mammography equipment. CT being computed tomography or CAT scan, as it used to be known. And then, the other sort of side of the business that was small and growing was magnetic resonance imaging. And so, the MRI product was diagnostic imaging, but the process technology to make that product and, the actual bits and pieces inside were very different. And so, I was in the diagnostic imaging side. So, if you think about diagnostic imaging sounds like fancy stuff, right? It's basically using an X-ray source. So something that makes, light of a certain wavelength that we can't see, and an X-ray detector of some sort. And, then looking at the difference in intensity through a patient. And, whether you do that as a static X-ray, like if you broke your wrist playing baseball and, slide into home plate and you whack somebody, and get the 2D X-ray and you see your wrists, and it's pretty clear. Or if it's a three-dimensional series of things that are stitched together in a computed tomography sort of sense. But those devices tend to be very high temperature. Some of them. An X-ray machine in the typical hospital uses about half of the periodic table in its bits and pieces. And so, the opportunity to work on metals and other materials that you've never even heard of is pretty cool. And then to be kind of part of a world-class business was also just fantastic, right? So not just the healthcare business was small, but one of the really neat things about working for a company like GE early in your career is that there's world experts everywhere. And so if you have a problem, right, the problem isn't, I have to go figure this out, a problem that you can't Google, right? The problem isn't, I can't figure this out, I've got to go to the library. It's more like, oh, I need to call my friend at GE Global Research who can help me find the world expert, elsewhere in the company. And so, it's problems are 2 or 3 phone calls away versus weeks of digging through books, at the time, which is just an opportunity to learn a ton of stuff quickly, which was really fun.
So in addition to you have this like super strong kind of material science technical background. So during your time at GE, kind of what other skill sets were you building at that time? I mean, it's this slightly different kind of organization going from a kind of PhD postdoc into a big company like GE, but kind of what sorts of, I don't know, challenge is probably the wrong word, but like what sorts of areas were you growing in terms of kind of your career and kind of experiences beyond the technical side?
Sure. Well, so I ended up doing a bit of supplier development out of necessity. So finding and onboarding suppliers, which, at the time really meant going and sitting with your supplier and going through an Excel document that had like 1,500 questions in it to fill the supplier checklist out. So did a fair amount of traveling and visiting, unique suppliers or suppliers with unique capabilities. Right. So if you're making a medical device that in order to get manufactured needs to be heated up to 2,000 degrees C and then whacked in a forging press or something, right? There's only a handful of places in the country or in the world where you can go get that done. And so, going and finding suppliers and developing them from, hey, I've got an R&D project to here's a production supplier. It was kind of an interesting diversion. Kind of not material science. The other big thing that transition that happened when I was at GE was kind of every site at one point had its own quality system. And we transitioned to a worldwide single instance of ISO 13485, so medical device quality system, which was, 3-4 years of literally 20 hours a week working on quality documents.
Yeah. That's
so, I'm I'll say that it's not my favorite topic, but I'm pretty well versed in quality systems. And we, developed through that process a lot of kind of best practices on thinking about quality, which now, I can't forget, right? They live on. And when you talk to somebody about a quality system or meeting a set of requirements, having a view of the most practical, easiest way to do it, as well as a view for keeping yourself out of audit risk, right? Nobody in the quality system world has a TurboTax button that, for $49.95, you can add audit risk to, protection to your quality system. No. Right. The audit risk is in how you approach, developing quality and ensuring quality, through processes and systems. and just not providing an auditor's rabbit hole to go down.
So when was
so
your
those are
first?
very, very different, but also very interesting.
Absolutely. So when was your first experience with additive?
Well, I'll say that I took a very difficult task on, and so X-ray targets or X-ray devices that make X-rays inside a diagnostic imaging equipment are discs that are typically made out of molybdenum alloy TZN, and they have an active surface, which is a tungsten alloy. And so tungsten, being a very high atomic number and being a very high temperature material, is a perfect for the application where you're putting a few thousand watts of electrical energy in per square millimeter. Right, so we're talking, 4 kilowatts per square millimeter, or about 1,000 times the incident energy on the wall of a nuclear reactor, is what the input energy was. And so that where the X-rays go, where the X-rays are created, the electron beam hits a sort of a path, and it makes a wear pattern in that device. And that wear pattern, even though it's just thermal wear, is something that causes life to be shorter than maybe you'd like it to be. And so my first additive project was trying to plasma deposit tungsten onto tungsten to repair X-ray targets. That was 2009, 2010. So in that time, there were very few companies that did metal additive, and very few companies that made metal powder compared to today. And so it was a particularly interesting challenge. I'll say that we had limited success.
And was the idea to bring that in-house, or like were you looking again on the supplier side to see who could kind of do
either
something?
way would work.
Okay.
I mean, in this case, either way would work, because the quantity of devices is only in the hundreds per week. So if you find a good supplier that has the capability that would do it as a total service, that's fine. For IP reasons, for the next generation target, the next generation equipment, maybe we would have brought it in house. But it's always a sort of game time make or buy decision.
And around that time too, I mean, GE had a lot of other additive I'm assuming kind of the timeline there, like they had some of the aerospace stuff was certainly kind of moving ahead at that time.
It was a couple of years. Yeah, it was early days where the aviation folks were working with Morris Technologies.
Right.
Prior to acquisition, there was a fair amount of research going on at corporate R&D. We did some projects early days on printing collimators, so trying to print really thin-walled structures in tungsten. And I'm sure there's lots of other stuff going on too. I'll say that I bought not then, but a year or two later, I bought the first plastic printer that I know of in the GE healthcare business, basically because I was working on a technology development project. And one of the things we realized that we didn't have a lot of space. We had to put a lot of technology and not a lot of space. And so the only way to do that successfully was to simulate. And so the first thing I bought on that program was a 3D printer, so we could make plastic prototypes of the equipment and the people and trash cans and desks, and literally simulate how that factory floor was going to work before we built it. So that was kind of my second application, was really kind of a more classic prototyping, supporting a lean effort and supporting, going from kind of greenfield R&D to how do I manufacture this device, in real time in Cleveland, Ohio.
And so at this time, was additive kind of a main part of your job description, or just like, hey, because the technology exists, I'm going to have to learn about it. It fits what we're doing. Yeah,
it was really a means to an end. The real goal for the target repair was to reduce cost, to be able to do, out of warranty repairs and get stuff back into the field cost effectively. And so same with the 3D printing for building a work cell. Right? It wasn't the job description; it was just the right thing to do for that project at that time.
How were you learning?
I haven't been a 3D printing evangelist, right? I say that I'm a user, or I'm a problem solver, and the additive manufacturing world came to me because of lots of problems to need being solved.
How are you getting that information at the time? I mean, there was certainly some literature out there at the time. There were certainly some suppliers, but were you just kind of talking to people
digging through the Thomas Register? Remember, I don't know if you remember when the Thomas Register was green books that you bought a subscription to. Kind of like
I've heard of it.
It was like
the business yellow pages, right?
Yeah, the phone book for yellow page for businesses. Yeah, it was a fair amount of going to conferences, right? So Rapid was in its early days. I'd go to FabTech and IMTS and kind of walk around. Also across the GE business, we had a lot of people doing things like plasma spray, things like powder fed DED, as it's called today. But we just knew that they were, using powder, sending it through a nozzle, and they were able to add material back to something. Right? It was unavailable technology, not necessarily thought of as part of additive manufacturing like it is today.
So, I mean, today your entire day to day, or I assume, maybe I shouldn't assume, is I would say is predominantly additive. So when
Yes.
did that kind of transition happen for you in your career?
Yeah. So I'll say, if I could, my nose itchy for some reason. If I could preface that, probably the best thing that happened to me in my career actually was getting laid off. Right, so I got laid off of GE Healthcare on the same day as 24,400 or some odd number of other people. One of the kind of cullings of the herd days, and that was a wake up call. I within a few weeks I had a network and I found someplace else to work. It was working on different high temperature materials, and it was pretty interesting. And then I got laid off from that company about 14 months after getting laid off from GE. So then I was like, okay, screw this, working for somebody else. Started my own business. Sound familiar? In the first maybe 6 or 8 weeks of building a book of consulting business, I had the opportunity to work with the GE corporate again and build a 3D printing innovation center outside of Pittsburgh. And so, building that facility then known as the Center for Additive Technology Advancement, or CADA, was just an opportunity. So Ed Herderick was kind of the thought leader. Barbara DeGroy was our champion vice president. And then Georgette Nelson and I and a few other people, found a business, started, recruiting technologists, started buying equipment, found a location, and worked out of 11 of us worked out of a construction trailer for about 10 months in the early days until the building was built. So yeah, my full-time working on additive was really probably it was October 2015, and full-time working on additive was actually going across the mud into the construction trailer, stepping out into my car in order to take conference calls because it was elbow to elbow people in there. And so, it's really been since 2015.
And what was the aim of this center? Was it to really be kind of a center for excellence for the entire company around additive technology?
Yeah. So, aviation had taken Morris Technologies and made the Additive Technology Center, and has seen lots of success, good project programs, good buy-in. And so the corporate wanted to take that and kind of replicate it across all of the business. So this was a no cost to the business, kind of open arms wide, talk to as many people as you can, find really good use cases, and help accelerate the business transition from legacy production to using additive for some semblance of production. And so, we went on a roadshow, the Ed Herderick roadshow for the most part. We talked to hundreds of GE locations, we visited many business installations. And I think, we ended up having 6 out of the 7 ASTM technologies under one roof to bring to bear for, a variety of different business challenges that, And so my team was essentially the engineering team. So we did intake of projects, we did evaluation. Our first year of operation, we evaluated more than 250 projects for should we print it? Could we print it? Is it the right thing to do for this business? And then executed a subset of those. The second year, I think we looked at more than 500 projects. So, literally that's 2 a day to evaluate that got submitted or that we heard of and we talked to somebody about. It was nuts, the amount of different ideas that got generated across the corporate enterprise, and then we evaluated and tried to help as many people as we could.
So at this time,
there was this business called Additive, right? That suddenly grew out of nowhere, and they decided to buy SLM and Arcam, which a certain capital management company drop kicked the SLM opportunity and then got sued, and so they ended up with Concept Laser and Arcam. And the whole shift changed from corporate innovation to really selling machines. And so I said bye-bye and joined John on this consulting adventure.
And so that time while you were kind of working on the Center of Excellence, were you consulting with them, or were you back at kind of GE full?
I was full-time back at GE. I was adding years to my pension qualifying service and all those good things.
Okay.
So, yeah.
And then kind of got out of that and kind of back into the consulting space with John. How did that kind of all grow up? In
2018, like everything good, it started with a number of coffees with John. So if you talk to anybody on the TBGA team, pretty much all of the early recruits were somebody that he happened to have coffee with a couple of times, or had lunch with a couple of times, and then suddenly we're all working together. But I've known John Barnes for a long time, right? We were roommates at Purdue for a year.
I didn't know that.
So, yes. So, yeah, we go way back. Funny story.
He wasn't the one that you took the job from, was it?
No. No, that would be really, really fun story. No. Funny story though is, I was in GE in this innovation role. I hadn't seen John or one of our other roommates for at least a decade. And in a 3D printing manufacturing seminar where, GE Global Research brought in 50 world experts, right? John flew in from Australia. My friend and fellow cyclist Dave, and former roommate Dave Bucci, which was working for the power business, which I didn't even know at the time. I'm sitting in this room, minding my own business, and I hear a familiar voice from behind, right? And you turn around, like, hey, there's John Barnes, right? And a few minutes later, it's like, oh, hey, Dave Bucci's. I know that guy over there. Dave Bucci's over there. And so, the materials world and the additive world is small, as you know. It was just kind of funny. Literally, there's maybe 250 people in that room, and 2 of them I hadn't seen in a decade, and they were both former roommates.
So we've had both John and Laura on the podcast before, so we have people can listen to kind of more of kind of what the Barnes Group does in terms of consulting, but maybe kind of specifically to you, kind of what sorts of projects do you generally get involved in, and what sorts of things are you working on?
Okay, let's see. I'm known as the Kirk of all trades. Basically, because I'm not good at saying no, and so and I like to work. So anything that comes in that's even remotely interesting, I'm game for. So I get a lot of the sort of dregs of the business. I'll call it, not in a bad way, right? But the things that either require finding an expertise or that don't fit within anybody else's expertise, I'll find a way to get it done. And so, things like ISO 13485 come in handy, right? So, a couple of years ago, we spent a good chunk of time building an AS9100 business plan and quality system for a small machine or a small service bureau, right? And so, instrumental in that. I've also been fortunately or unfortunately the one to dig through all the regulations, and over the past couple of years have built a pretty good, robust tool aimed at looking at facility safety with respect to additive manufacturing. And so we've got 150 question checklist and a rating system that we can pretty much drop into any facility around the country, mostly US based rules at this point, and do an evaluation and say, hey, here are the things that are imminently scare worthy. Here are the things that you should probably fix in the future. And here are the things that, if it was my facility, I would take care of. You can ignore them if you'd like, but it's not the right thing to do. So I do that end of things. On the AM Now program, for example, I'm the engineering leader for binder jetting of 4130 steel. So that's literally bringing a new alloy through binder jetting into the lexicon of AM in support of some Army needs. And I also support a series of plastic parts that we're doing also for the AM Now program in support of Army. And so, engineering, writing statements of work, doing technical drawings, specification analysis, supplier selection, all that kind of stuff.
And
every day is different.
So thinking about kind of bringing it back a little bit to the material science side, kind of what is it about kind of additive that makes the material science side of things interesting for you?
It's a combination of getting materials, process, and shape at the same time. Right. So, pressing and sintering is sort of that way. You can say some of the shape forming processes too. But, typically if you're going to forge something or extrude something, the material is already there. Right. You've got a standard chemistry already established. Whereas an additive, your input material changes or can change through the process. And so, it's shape formation plus process equals materials. And how we can vary that path and make different materials using the same input chemistry and process is really kind of where my head is what's interesting. Whether it's a polymer process, or a metals process, or ceramic process, or a composites process, doesn't really matter. Right? It's the sort of the path dependence and the combination of processing plus shape making that's interesting.
So when you were kind of describing what you do on a day-to-day basis, a little bit of the dregs, but kind of these important things that often are overlooked, like facility safety, the quality side, certainly, and the system and the documentation of all additive adjacent steps in the process. Like that's often from what slows this adoption. Slows it, makes people pause, make people kind of dig into it a little bit more. But kind of what are you seeing kind of on over the last kind of few years in terms of that piece of the overall industry? Are people kind of becoming more aware of it? Are they asking tougher questions when it comes to are they assuming that, hey, it's not just I buy this machine and kind of put it in? It's like the actual workflow of any given part, right? It could be, hey, it spends 8 hours in a machine, but like the actual touch time of developing the design, developing or doing the post-processing, machining, like that could be 20, 30 hours and way more than it spends in the machine. So what do you, I guess, probably general question, kind of what are you seeing in terms of things happening in the industry, kind of where from your vantage point, from just overall adoption into production these days?
Yeah. I think everybody's got to run their own race. And so it's hard to answer in one set of words or one capability. I think you're right in supposing that there's a little bit more focus on quality. I think the last couple of shows I've been at, see a lot fewer people who are willing to just go and buy a machine and try it. Oftentimes they've done that with a desktop printer, or they've done that with some low cost device. They started to understand what they want or what they need for a real product, and they think about it more as a system problem than I just go buy an additive machine and everything's done. I'm working right now with a company that's building a new facility, and they started their additive journey using a polymer machine, quickly got interested in metals, happened to be located in a business park where there's a wire EDM across the parking lot, and so they didn't have quite as many struggles as many do with the downstream processing side. But they're now building their own facility. And so I've spent a few hours with them in terms of answering questions, and generally, think about what's people flow like, what's the material flow like, what areas do you want your customers in, what areas are you going to consider your secret sauce? Where does the UPS guy or girl deliver packages versus where does your most important raw material come into the building? So thinking strategically about how to lay all of that stuff out can go, a long way towards business success, elimination of foreign objects in your process, cleanliness, safety, and really good, quality results, right? But it all results from some early planning.
Yeah, and it's always a balance too, between those types of customers that have the blank space, the white space to start something essentially from scratch, versus someone that's trying to shoehorn in is like, hey, we got this $1 million metal machine we got to put in here. We've got space for the machine, but there's no space for post-processing, or you have to take across the parking lot. It's this real big balance that if you just talk to the OEMs, like they want to get the machine in there, so it'll fit, but you can't do anything.
It'll fit, but you can't. But what can you do with it?
Yeah.
Well, I mean, the other challenge of a machine is that when that machine is down, and with the current labor shortages, that's a real possibility. Right? I mean, we've been hearing from customers that several of the machine OEMs are having big problems supporting their customers with enough service techs. And so you might wait 6 weeks for service. So if you have one machine, is that really enough to rely on for your production? Or should you have two? I have a friend in the casting industry whose famous quote is 1 equals none, right? Because he's gotten just screwed too many times with a piece of equipment that went down and then missed a critical customer delivery. So he always buys two of anything he can afford.
It's a good thought. If you have the money.
Yeah. If you have the money, right? Or you strategically buy two things that are maybe smaller than your needs, and you balance their capacity, or balance their use. That way you always have one that can work. Yeah. The other sort of interesting side that we often get into is helping people decide how to change their business, whether that's, a third generation owner that wants to retire, but doesn't have the next generation of their family to pick up the business, or, they're ready for a change and they want to get acquired. And so they're not doing all the day-to-day management. And so, helping people find what their value is, what the actual, destination that they really want is, and then a good partner to get there with has been also pretty fun sort of subset of diversions lately, especially last year with so much M&A last year. It was crazy.
And so just a couple kind of final questions. So first one is, kind of as you look towards the rest of the year, we're in February going into March here, like what are you excited about related to the industry, related to kind of the work you're doing, or related to the Cleveland Indians, maybe upcoming, or no, it's not the Guardians. It's
the Guardians now.
Upcoming season, maybe. We'll see if they play.
Yeah, I gotta get me some Guardian swag now that Chief Wahoo is no longer allowed to be displayed. Yeah, I don't know that I have any predictions on the MLB season or when it's going to start. Hopefully someone will speak sense into owners and players union and we'll actually have a season this year. I think for the industry, one of the things I'm excited about is Formnext North America. right? I think that show could really change kind of the makeup of how we think about trade shows versus technical conferences in North America. It's IMTS is sort of too big, and as a small additive company, you're going to get lost. But I think something like Formnext that grows organically over the course of the next few editions could make a really, really nice addition to the North American, trade show arena. So that's something I'm really interested to seeing how it plays out. Also, I think that, that may cause others to reevaluate whether their shows have value. And so we'll see. I think that one of the things I'm hopeful for is that there's a reduction in total number of trade shows and technical conferences, because if I went to everyone that's additive, I would never be home. Right?
You get sick of seeing the same people there.
Well, yes, exactly. I think that there's, on the machine side and on the downstream processing side, and in software, I think there's real value coming in areas outside of laser powder bed fusion. Right? And I think finally for DED solutions, that we're on the cusp of having good software solutions to build parts. So it's not, a year of programming to make a part. It's okay, get geometry, slice the build, go, like it is in laser powder bed fusion or in material extrusion. I think also in cold spray, we're starting to see, that become a bit more of a mature subset of the industry along with DED. And so, those sort of plug and play ready solutions that make it easier for someone to buy and utilize is really going to go a long way for the applications that are not laser powder bed fusion or not material extrusion. And the other thing I'm really interested in is just the bevy of temperature resistant, tough, strong materials from both that photopolymerization kind of processes as well as pellet extrusion to take over incumbent aluminum solutions, take over some incumbent things in more high volume industries, which I think is we're on the cusp there too.
Sure.
From a materials perspective, again, I brought it back to materials. Strange.
I like it. Keep it consistent. So last question before I let you go for the weekend. If you could give kind of one piece of advice to someone just kind of evaluating or starting out their career, maybe thinking about additive, like, hey, is this going to be something that I should invest my time in learning more about, or kind of getting a job in, kind of what would that be?
Oh boy, career advice. That's something I don't like to give. I'll say that maybe I can't give direct career advice, but what I look for in people, like when I've been a hiring manager, is someone who has a strong expertise in one thing, right, but broad awareness in a variety of others. So sort of the T people or tree people, if you want to, somebody deep roots but broad interests. You tend to bring the best to the team. And so I'll say that developing not only, your core that you're really good at, but also being a human, a citizen, right, and having broader interests really brings something to whatever team you're with. The other thing I'll have to say is is to interview the company where you're thinking about going, and find as much information as you can, because culture makes as much of an impact as anything else when you're in the work world. And so finding a culture that works for you and where you would like to work goes a long way when you're early in your career towards happiness and success.
Awesome. That's great advice. And I want to thank you for joining the show today, and look forward to seeing you at one of these upcoming conferences, one of these
Absolutely.
too many upcoming conferences, right?
Sure. Thanks for the opportunity, Mike. This was fun.
All right. Talk soon.